Question number 11 of find the inverse if the inverse is find the inverse of the matrix if the inverse is exists. So this is the question number 11. The matrix A is given. We have to find we have to check it. Does the inverse exist? For checking to for inverse is we have to find the determinant of a matrix. If the determinant of a matrix is non-zero, then there will be inverse. Then we will find the inverse by the with the help of the adjoint. To find the adjoint, we need a cofactor. So matrix, this is the matrix given. We will consider this as a matrix A. So matrix A, this is the question number 11. So let A is equal to 1 0 0 0 cos alpha sin alpha 0 sin alpha minus cos alpha. So this is the matrix A. Let's find a determinant. So this is the determinant, symbol of determinant of along the first row. So this will be the A11. So this is 1 bracket, eliminated this row and this column. Now multiply the corner. So it will be minus cos into minus cos alpha. So it will be cos square alpha minus cos square alpha. So for the formula minus, so it will be sin into sin, sin square alpha, bracket close. So minus here formula 0, since it is a 0, eliminate this row and this column, the remain multiply the diagonal. So 0 into minus cos alpha, 0 minus 0 into sin alpha, so that is 0 plus 0. Now eliminate this row and this column, multiply the diagonal. So 0 into sin alpha 0 minus 0 into cos alpha 0. So 0 minus 0. So it will give 1 into, from here minus 1 we can take the common, then we will give cos square alpha plus sin square alpha plus minus 0 plus 0. So this will be 0. So it will be 1 into minus 1, it will give minus 1 into sin square plus cos square, that is cos square plus sin square also 1, sin square plus cos square also 1, because addition is a commutative. So 1. So does not, it will be minus 1 does not equal to 0. So A is non-singular matrix. Therefore A is non-singular matrix. A is a non-singular. Therefore inverse or A inverse exists. So for finding the inverse, we need a adjoint. For finding the adjoint, we need a cofactor. So we need to find A11, that is a cofactor. A11 is equal to, that is A minus 1 power 1 plus 1 M11. So this is the minus 1 plus 1, minus 1 power 2, that is 1 M11. Eliminate the first row and first column. So cos, so this is the, eliminate the first row and the first column. Now so cos alpha sin alpha minus cos alpha. So it will give 1 bracket minus cos square minus sin square. Take the minus common. So 1 into minus 1 bracket sin cos square alpha plus sin square alpha. So this will give minus 1 into 1. Sin square plus cos square equal to 1. So it will give minus 1. So A 1 2 minus 1 plus 2 M 1 2. It will give 0. Here is the minus 1 power 3. So it will give minus 1. Eliminate the first row and second column, 0 0 sin alpha minus cos alpha, minus 1 bracket, it will give 0 minus 0, that is minus 1 into 0 is equal to 0. A13, that is minus 1 power 1 plus 3, M13, here is positive, first row first column, 0 0 cos alpha sin alpha, so it will give 1 bracket, it will be 0 minus 0, so equal to 1 into 0 is equal to 0. Now A21, we have the matrix, the matrix is A is equal to 1 0 0 0 cos alpha sin alpha, 0 sin alpha minus cos alpha, this is the matrix. So this minus so the minus 1 power 2 plus 1 M21 is equal to, here we will give negative, or 2 plus 1 is 3, 3 is odd, so it will give minus 1. Now eliminate the second row, this is the second row and first column, second row and first column, 0 0 0 0 sin alpha minus cos alpha, so 0 0 sin alpha minus cos alpha, minus 1 bracket, it will be 0 minus 0, so minus 1 into 0, so it gives 0. Now we have A or 2 2 equal to minus 1 2 plus 2 M22. Now eliminate the second row, this second row and second column, second row and second column, second row and second column, so it will give 1 0 0 minus cos alpha. Here is the positive 1 0 0 minus cos alpha, so it will give 1 bracket 0 minus 0. Wait. No, this is 1 minus 0 minus 1 into cos alpha, it will give here it will be minus cos alpha equal to, this is 1 bracket, 1 into minus cos alpha, so minus cos alpha minus 0, so it will give minus cos alpha. Now A23, that is, this is the matrix A23, so A minus 1 2 plus 3 M23, so here 3 4 5, so it will give my negative, eliminate the second row and third column, second row and third column, 1 0 0 sin 1 0 0 sin alpha, so minus 1 bracket sin alpha minus 0 into 0 0 is equal to minus sin alpha. Now second row complete, now third, that is A31, minus 1 3 plus 1, that is M31, it will give here positive, eliminate now third row first column, 0 0 cos alpha sin alpha, 0 0 cos alpha sin alpha, so equal to 1 bracket 0 minus 0, because cos alpha into 0 sin alpha into 0, so 0, it will be 1 into 0, that is equal to 0. A32, minus 1 power 3 plus 2 M32, here it will give minus, because it is the odd, whenever the power became odd it gives the minus, whenever the power became even it gives the positive. So eliminate the third row. So this is the third row and second column. 1 0 0 sine 1 0 0 sine alpha. So it will give minus 1 bracket sine alpha minus 0, so minus sine alpha. A 3 3, so minus 1 power 3 plus 3 m 3 3. So it will give positive because the power is even. Now eliminate this first row, third row and third column. 1 0 0 cos 1 0 0 cos alpha. So 1 bracket cos alpha minus 0 is equal to 1 into cos alpha. So it will give cos alpha. So we got alt A11. We got A11, that is A11 minus 1, A12 0, A13 0, A21 0, A22 minus cos alpha, A23 minus sin alpha, A31 0, A32 minus sin alpha, A33 cos alpha. So arrange it. Now it's to write the adjoint. So arrange in the matrix. So adjoint of A equal to so we got all the cofactor. So now it's adjoint of A. Adjoint of A is equal to A11. So we got minus 1 0 0 0 minus cos alpha minus sin alpha 0 minus sin alpha cos alpha. So transpose. Now the row will become column 1 minus 1 0 0. The row will become column. So 0 minus cos alpha minus sin alpha 0 minus sin alpha cos alpha. So this is the adjoint. We need the inverse. So inverse is equal to adjoint of A divided by determinant of A. Determinant of A is minus 1. So 1 divided by minus 1. This is the adjoint of A. Minus 1 0 0 0 minus cos alpha minus sin alpha 0 minus sin alpha cos alpha. So equal to positive. This is the minus. Take the minus inside. So it will 1 0 0 0 cos alpha sin alpha 0 sin alpha minus cos alpha. Now question number 12. Question number 11 complete. Question number 12. Question number 12 stated, in question number 12, let A matrix is given and B matrix is given. A matrix is 3 2 7 5 and B matrix is 6 7 8 9. Verify that AV inverse equal to B inverse and A inverse. So first we have to verify this. Verify that means we have to find the AB, product of AB, and find the inverse of this, and product of then find the B inverse and find the inverse and multiply this. These two result is equal. So this one we have to prove it. So this is question number 12. So in question number 12, first we need a matrix. That is, this is the question number 12. A matrix is given, that is, this is the A matrix 3 7 2 5, and B matrix, that is 6 8 7 9. I need a product of this AV. So there is A into B, 3 7 2 5. This is the A, and this is the B, 6 8 7 9. Now multiply this. So the row will become column. The row will be multiplied with the column. So 3 into 6, 3 into 6. so it will be 18. In the middle it is a plus, 7 into 7, the row will go and the column. So 7 into 7, 49. Now first row and second column, 24 plus 63, 6 to the 12 plus 35, 16 plus 45. Now add this number, so it will give 67, 87, 47, 61. We got the matrix. Now we have to find the inverse of this, so we need the determinant. So determinant of AB, so it will be diagonal 67 into 61 minus 47 into 87, so it will give 4087 minus 4089 is equal to minus 2. So that's not equal to 0, so we have the inverse, so we need the adjoint of AB. So adjoint of AB, interchange this, that is 61, 67. Here the sign will be negative, minus 87 minus 47. So this is the adjoint. Now inverse of this, so the inverse will be A inverse equal to adjoint of A divided by determinant of A. So adjoint of determinant is 1 by minus 2. Adjoint of A is 61 minus 87 minus 47, 67. So this is the A inverse, sorry, no, this is AB whole inverse, AB whole inverse. So now we need a now find the A inverse and B inverse separately, then we have to find the product and we have to check it out, is it same or not. So take it inside, since this is the adjoint inverse, so it will be inside, take it inside. So 61 by 2, it will give minus 87 by 2, so this will be positive, 47 by 2, this will be positive, minus 67 by 2. So this is the inverse of AB, inverse of AB. Now we have to find the inverse separately and multiply it. So first I need a matrix, so this is the A matrix, 3, 7, 2, 5, and B matrix 6, 8, 7, 9. First determinant of A, that is 3, 5, 15 minus 14 equal to 1, does not equal to 0. B determinant of V, multiply it, 54 minus 56, it gives minus 2, does not equal to 0. So A inverse also exists, B inverse also exists. For adjoint of A, adjoint of A, that is interchange these two, 5, 3. Give the negative sign of these two, minus 7, minus 2. Now adjoint of B, interchange these two, 9, 6, give the negative sign, minus 8 and minus 7. So this is adjoint. Now I need a inverse. So A inverse is equal to 1 by determinant, so 1 divided by 1, adjoint of A, 5 minus 7 minus 2, 3, divided by 1, it remained the same, so it will be 5 minus 7 minus 2, 3. And here adjoint of B, so A inverse, B inverse, 1 divided by minus 2, 9 minus 8 minus 7 and 6. So this is the B inverse. We got the inverse and we got the B inverse. Now we are going to multiply B inverse and A inverse. So B inverse into A inverse. B inverse we got 1 minus 2, that is 9 minus 8 minus 7 6 into A inverse, that is 5 minus 7 minus 2 3. Keep it at this side, minus 1 by 2 outside, multiply this first row and first column. 45 minus into minus, it became plus 16. First row and second column, minus 63 minus 24. Now this and this, it will give minus 35 minus 12. Minus into minus become plus 7 49 18. Now minus 1 by minus 2, add this number, it will give 61. Add this number, minus will be sign here, add this number because both are minus, so minus and minus will add up, minus 87, this will give minus 47, this will give minus 67. Now take the 2 inside, so it will give, if you take the 2 inside, minus 61 by 2, minus and minus became plus 87 by 2, 47 by 2 minus 67 by 2. So we got the same, minus 61 by 2, 87 by 2, 47 by 2, minus 67 by 2. This is the result of B, inverse of B into inverse of A. So we got the A whole inverse, that is minus 61 by 2, 87 by 2, 47 by 2, minus 67 by 2. It's equal, therefore A B whole inverse is equal to B inverse into A inverse. Question number 13, that is, if A is equal to 3 minus 1 1 2, show that A square minus 5A plus 7I equal to 0, hence find A inverse. Matrix A is given, from with the matrix A we have to show that this equation is equal to 0. From this we have to find the A inverse. So for this, first I need the A square, so find the A square first. So this is the given matrix. This is question number 13. The given matrix is A is equal to 3 1 minus 1 2. I need the A square, we need the A square. So that is A square is equal to A into A. So it will be 3 1 minus 1 2 into 3 1 minus 1 2. Multiply it. Row will be multiply column, first row first column, first row second column, first row first column, 3 into 3 9 minus 1 into 1 and first row second column, 3 plus 2 minus 3 minus 2, first second row second column. This is the matrix multiplication, so minus 1 plus 4. So it will give 9 minus 1 8, 3 4 5, and this is minus 5 and minus 5 and 4 minus 1, this is 3. So we multiply it, so we got the A square. Now put in the equation, that is the equation is A square minus 5A plus 7I. I is the identity matrix. A square we got, that is 8 5 minus 5 3 minus 5. A is how much? 3 1 minus 1 2 plus 7I is 1 0 0 1. This is the I. So it will be 8 5 minus 5 3, multiply it, so it will be 15 5 minus 5 10 plus multiply it 7 0 0 7. So now add all this number, do it together. So it will give 8 minus 15, the first all the first position 7. Now 5 minus 5, because this is the minus sign, plus 0. So minus 5, minus and minus become plus 5 plus 0. So 3 minus 10 plus 7. So it give 15. 8 plus 7 is 15, plus 15 minus 15 0, minus 5 plus 5 0, here also 0 0. So we got the equation, that is a square minus 5a plus 7i is equal to 0. From here we have to find the a inverse. So that is a square minus 5a plus 7i equal to 0. Now multiply it. Okay, instead of a, it will write a square. A square can be written as a into a minus 5a plus 7i equal to 0. Multiply each and every term by the a inverse. So it will be a inverse minus 5a inverse plus 7i a inverse equal to 0 a inverse. A into a inverse will give I, and if any a inverse I into a inverse will give a inverse. So now this will become I, that is a into I minus 5i plus it will give 7th a inverse equal to, multiply 0, it will give 0. So keep the a inverse that side, take the inverse that side. So it will give minus, multiply will be a minus 5i. If you multiply it, it will give 5i minus 5i. Take it that side, so it will be equal to minus 7th a inverse. So we can write minus 7 a inverse is equal to a minus 5i. Take the 7 that side, so it will a inverse is equal to 1 by minus 7th bracket a minus 5i. So we need 1 by minus 7th bracket. A is how much? A we have, that is 3 1 minus 1 2 minus I is, this is 5i 1 0 0 1 bracket close equal to 1 divided by minus 7. So minus, it will be 3 1 minus 1 2 minus 5 0 0 5. Subtract it, minus 1 by 7, 3 minus 5, 1 minus 0, minus 1 minus 0, 2 minus 5. So it will be minus 1 divided by minus 7, 5 minus 1, it will give how much? Minus 2. This will give 1, minus 7, minus, this is minus 1 and 2 minus 5, that is minus 3. That will be, take the minus inside, it will give 1 by 7, only take the minus, so it will 2 minus 1 1 3.